Hello there and welcome to this series of videos going through the content of A-Level Maths. Here we're looking at recurrence relations. We can answer questions from exercise 3G. So what is a recurrence relation? Well, it's a way that we can make a sequence of numbers in which the recurrence relation is defined as a function of the current or the previous term. So here's how the notation is going to look. It's going to have a u, or any letter really, but then subscript of n plus 1. Now what the subscript n plus 1 tells us is effectively what term in the sequence we are currently at. So if we're at the first term, we're looking for u1. If we're at the second term, we're looking for u2, etc, etc. So what this un plus 1 means is that this is the way that we are going to calculate the next term that's going upwards in our sequence. And we compute the next term in the sequence by whatever function of un we're going to use. So think of un plus 1 as the next term, and then think of the function as the rule that helps generate the next term in the sequence using the current term in the sequence that you've got. So in this case here, for part A, we're going to write out the first 4 terms of this sequence here. un plus 1, so the next term up in the sequence, is equal to the current term in the sequence, add 4. Now, when you do this, you need a starting value, so our starting value is 7. So effectively here, this means that each time we move up 1 in the sequence, we're going to add on 4 to the previous number. So if we start at 7, 7 add 4 gives us 11. 11 add 4 now gives us 15. 15 add 4 gives us 19. So this here effectively is u1, this here is u2, this here is u3, and this here is u4. So it makes sense if we were to work out this 15 term here, that it would be u3 is equal to u2 plus 4. And hopefully by that point in time you know what u2 is, so it's going to be 11 plus 4, which will give us our 15 value. So that's why u3 is 15. For the next term here, new question, it's a different type of sequence. It's un plus 1 equals n plus 4, but this time we're going to start at 5. So the sequence is slightly different, going up by the same amount each time, but this time we're starting at 5. So the starting value is really important to help this sequence get going. Okay, let's have a look at a slightly more difficult one now. So we're starting at the value 2, and we're going to double the current term that we're at, and then add 3. So if we're starting at 2, this is effectively u1. So to get u2, we're going to do 2 times the previous term, which was 2. 2 times 2 is 4, add 3 gives you 7. To work out u3, we're going to do 2 times the previous term, which was 7. So 2 times 7 is 14, add 3 gives us 17. To work out u4, hopefully we will be, 17 times 2, so it's always working with the previous term in the sequence. 2 times 17 is 34, add 3 and you get 37. And next term is 77, and you carry on going upwards. So you double the term previously in the sequence and then add 3, and that's how this recurrence relation sequence works. Right, let's move on to some trickier questions now to do with algebra and using these recurrence relations. In this case here, we have a sequence, A numbers, so not U numbers anymore, A numbers, A1, A2, A3, dot, dot, dot. We know the starting term in our sequence is P, and we're told that the way that we're going to calculate how to get up to the next value in the sequence is we're going to square the current term and then subtract 1. So for the first one, we'll square P and then subtract 1. P is less than 0. Show that A3 is equal to P4 minus 2P squared. So the first thing we'd need to do probably is to work out A2. So let's work out A2 first. The second term in our sequence is calculated by using the previous term in the sequence and squaring it, and minus 1. So this here is going to be P squared minus 1. Okay, now moving on to A3, what we're going to do now is to work out A3, we're going to use A2 and substitute it into this formula now. So, substituting in A2 into the formula, we're going to get p squared minus 1 squared, all minus 1. So expand the brackets and simplify. And we get what we were looking for, p to the 4 minus 2p squared. So this is our value for A3. Okay, so the next question here is, given that A2 is equal to 0, find the value of p. Okay, well let's set A2 equal to 0 then. That means p squared minus 1 is equal to 0. We have to do a little bit of factorising here and we get two answers. P is 1 and p is negative 1. But we know that p is a negative number, so therefore p cannot be 1, so this solution is got rid of. So it's only minus 1 as our final answer. Just be aware on these conditions on the algebra, sometimes they help you eliminate one of the answers from a quadratic. So we know that p is 1 now, so p is minus 1 now. And we're asked to now add up the first 200 terms in this sequence. It seems quite a difficult sequence to work out the summation of. Let's just write out the first couple of terms and see if there's a pattern. So A1 is equal to minus 1. Let's work out A2 now. So square the minus 1 and minus 1. So that will give you 0. 0 squared is 0, and then we minus 1, so it's minus 1. Then for A4, we substitute in A3 into this formula here. So minus 1 squared is 1, minus 1 is 0. Okay, it looks like there's a bit of a pattern here. Now A5, I'm assuming, is going to be minus 1. And A6 will be 0. So it seems here that this is not a geometric formula or an arithmetic formula, so we can't use any of the summation formulas we've seen earlier. We've just spotted a pattern and we're now going to try and generalise that pattern. If we've got all the numbers up until 200, that means there's going to be 100 terms where there's a minus 1 and 100 terms where there's a 0. So every other number gives us a minus 1 as a sum. So effectively we have 100 pairs of minus 1. So our total here is going to be minus 100. So in this case here, you were doing a summation question without necessarily using one of the formulas. You were just writing out the first couple of terms, spotting if there was a pattern, and then adding up that pattern that you've spotted. Okay, the final question before we have a go at some of our own is find the value of A199. Let's just go back and see what we've got here. We spot here that the odd numbers will give us a minus 1 and the even terms in the sequence will give us a 0. So we can just say straight away then that following this pattern, A199 is equal to minus 1. Okay. Right then, your turn to have a go at these couple of questions here then. In the first question, you've got to guess the, or not guess the, but work out the recurrence relation, and then there's a little bit of a simultaneous equation question for question 5. Pause the video and try these out. Right, okay, so for part B, hopefully you've spotted that to get up to the next term, you use the current term and subtract 3. So that's what your recurrence relation formula looks like, but you need to also find the first term, so u1 equals 20. For question F in this exercise, the question is a little bit more difficult. It doesn't go up by the same amount each time. So what we've got to do now is, I don't think this will be an exam type question, we've just got to try and spot it. So in this case here, they all look like something to do with 2's. They're almost very close to 2's. This is effectively 4 minus 1. This is 8 minus 1. This is 16 minus 1. This is 32 minus 1. So it looks like here we are doubling the term from before, but it's not quite that easy. That'll be 6 and you add 1. Yep, that's it. So it's going to be un plus 1 is equal to 2 times the term before, but then it's add 1. Yeah, that's it. Okay. Okay, so we need to define the first term as well, u1 equals 3. Okay, so question 5 here, sequence starts with un plus 1 is equal to p un plus q starting at 2. Given that u2 is equal to minus 1 and u3 is equal to 11, find the values of p and q. So let's go ahead and start working out what u2 is. Now, to get u2, we substitute in u1, so it's going to be 2p plus q, and this is equal to minus 1. u3, now what we're going to do with u3 is, we could either substitute in this big algebraic thing here, or actually it'd probably be easier to substitute in the minus 1 here. So to work out u3, substitute in u2, and we're going to get minus p plus q is equal to 11. So in this case here, I think what we'll do is we'll call this equation 1, and we're solving simultaneous equations now. Let's do equation 2 minus equation 1. So in this case here, we're going to get minus 3p. Q's cancel out, and then we're going to get 12 here. So p is minus 4. Minus 4. Yeah, that's what we get for P. And for Q, let's work out what we get for Q. So let's substitute in into the second equation here. We're going to get 4 plus Q equals 11. So Q is equal to 7. Okay, so there we are. So let's just check that this formula works. In this case here, we've got un plus 1 is equal to minus 4un plus 7. Substitute in the number minus 1, and we're going to get minus 4 times minus 1 plus 7. And in this case, it's going to give us 4 plus 7 is 11. Oh, perfect. The formula does work. Good. Excellent. Okay then, so have a go at some of the questions from exercise 3G. Persevere through the difficult ones. Make sure you pick out the problem solving and the exam type questions, and ask your teacher for help if you get stuck on anything. Thanks very much for watching.